So this is question 3. So use transformations to graph the function, determine the domain, range, horizontal asymptote, y asymptote of the graph. So the function is going to be f of x equals 2x plus 1. Notice this graph, the parent function is 2 to the x. So since the parent function is 2 to the x, what we should pick up on is we have some points. We know 0, 1 is there, but notice how this plus 1's on the outside, so it should make the graph move vertically up 1. So we have an idea of what an exponential function looks like after question 1. Let's see what we can do here. So our graphing tool, an exponential function is going to be this guy right here. So we're going to click this tool. That's the exponential function. So we now need to click the graph itself. So just click somewhere. Like I said, 0, 1 is usually a point to plot. So, but now what we have is the translations here. Notice that the plus 1 actually makes the graph move up 1. So I should have up 1. That's already got that. That looks good. Here, I'm sorry, these are the compressions. So that has to stay as 1. The horizontal stretch compression, because those are coefficients. When you multiply by 1s, they don't affect anything. Yeah, the vertical shift is what we're talking about. So I need to slide this bar over 1. That makes the graph. So if I do that again, notice how it does move up 1 there. I click the mouse and it shows me there. So you know, my little mouse turns to a finger pointer. If I click that, it shows me that I'm at 1. Notice that the horizontal shift remains at 0, so we don't want to change that. And there's not any reflections over the x or y axis because there's no negatives in the problem. Notice how the base is too. So if we save this, that should be what our graph looks like. So now if I can kind of move on. So if I was wanting to graph this y equals 4x plus 5, notice that the tool that we want to use is going to be this tool here. So you do that, you're just going to click the graph. I usually just click here at 0, 1. When I do that, we're now going to have this palette here pops up. So this here should just stay as 1. This should stay as 1. But notice how we had a plus 5. And since that's outside, this plus 5 means the graph should move up 5. It's going to be a vertical shift up 5. So this has to be moved over to 5. And this should stay as 0. And we're not going to have any reflections over the x-axis. Over the x-axis means there's a negative on the outside. If there's a reflection over the y-axis, that means there's a negative on the inside, and we don't have either one of those. So those will stay blank. And again, the base was a 2. So when I do that, this graph should move up to, instead of 0, 1, it should now move up to 5 from there. 1, 2, 3, 4. So it should now be 0, 6. Also, what's going to move is the horizontal asymptote. It was at y equals 0. It's now going to be moved up 5, so it's going to be at y equals 5. So there should be this little boundary line. The graph probably won't show it, but it'll do that. So if I sketch the graph should have this appearance here. Something like that. Now, if I want to use my calculator, I can go y equals, clear. I can do 4 to the x plus 5 and graph that. Notice how it kind of does move this graph up there like we have. So that's what our graph is going to look like. Now, as far as the domain, let's see, we've got a different function here. Oops. So let's fix these. We'll pause the video for a second. So as I said, our function is going to be this y equals 4 to the x plus 5. Notice how this graph does move up 5. As I said, this is going to be our tool we're going to use is the exponential tool. And again, the only thing we really had to do is change the vertical shift to go to the right 5, or actually this means up 5 since this is a vertical. So I'm changing this to 5, but it actually will move the graph up 5. The domain of the function, again, this is input. Notice that the domain is left and right. And again, this is our graph over here as well. Notice that, again, the domain of our function, notice how there's an arrow on the left side. There is no left boundary. And this does tend to slide to the right, just not very much, but it does keep going to the right as well. So there's not any domain restrictions. Remember, to have a domain restriction, the x would have to be in the denominator of a fraction, or the x would have to be inside of a square root symbol, and it's not. So our domain, again, using interval notation, is going to be negative infinity to infinity. As far as the range goes, notice that there is a lower bound here, because like I said, the graph that 1 point moved up to here, we had a horizontal asymptote passing through this 5. So our graph kind of took on this look here. So notice how there is a lower bound, because the lower bound is this y equals 5 boundary line. So notice how the graph has to be above 5. And notice how there's not an upper bound. So it looks like we have to go from 5 up. We can't include the 5 either, because that's a restriction, it's a boundary. So 5 to infinity would be the range. So determine the horizontal asymptote. Like we said, this horizontal asymptote is just going to be this y equals 5. Again, if you look at your table, if you look at your y values, let's see if I do have the right graph there, 4 to the x plus 5. Notice the graph actually changes to 5. It should actually be 5. It should be getting closer to 5, but it's so darn close to 5, they just call it 5. But notice how, as you go to the left, there is a boundary, which we use y is equal to 5 as a boundary line. Again, the intercept is where it was at 0, 1. So now notice how it's moved up to 0, 6. So the intercept here was then just simply -6 was the, I'm sorry, it was a positive 6. So also, if you look on your table, when x was 0, that's how you find the y-intercept. 0, 6 appears there. So 6 would be the y-intercept as well that you could get off your calculator. So if you know your transformations and stuff, it does make this go a lot quicker, where you don't have to actually use the calculator as a tool, but the calculator can be a tool to double check your work. All right, I think that concludes question 3.